In this video, we will use the NetworkX package to calculate the shortest path between different nodes in the Florentine family's network. The idea behind the analysis is that a node that entertains the shortest path with many other nodes in the network is located in a strategic position in the network, and this position reflects things like influence and power. For example, if a node is close to many other nodes, this node can broker in between communication or relationships among these nodes. Those concepts are important in social network analytics, and many of the analyses we use look at structures as a proxy of some social or organizational processes. Let's take a look at this example here. First, we need to import the network from the file data Florentine GraphML. So I'm going to import NetworkX in the beginning, and then I'm going to import my network using the function read GraphML. I'm going to read the graph from the file, and to make sure I'm going to draw the network. You see I've got the network correctly. It's actually nx.drawNetwork. Okay, so we got the network, and I'm just waiting for a good layout here. This is reasonable enough. Next, let's take a look at the questions. First, what's the shortest path between Medici and Peruzzi? Let's copy the family's name here, and I'm going to use the function nx shortest path function. And the shortest path function will take the network itself, the source and target, and if there is any weight information that I want to use. I don't have any weighting here, so I'm going to include the network, the source, and the target. The network itself is called NET network, and the source and target are the two families, the Medici and the Peruzzi. And it's basically telling us that the shortest path between Medici and Peruzzi goes through, where is Medici here? Barbadori here, and then Castellani, and then Peruzzi. So the length of the shortest path is 3. So if I do len of that, it's going to be 4 because I have 4 nodes. I want to take one of it. So that's the length of the shortest path in between these two nodes, the two families. Now I know these nodes here. The next question is asking us to generalize a bit. It's basically asking us to report the shortest path between Medici and all other nodes, meaning all other families in the network. One way to do it is to take a look at my nodes, because I can get the nodes here, and then apply this function for each one of the nodes. So I can do len. I'm going actually to write a function. So length, let's call it distance, in between node 1 and node 2. And I'm going just to return the shortest path in the network and node 1 and node 2. Maybe a good idea to make network a parameter, but since I only have one network in this exercise, I'm just going to use the network, the global variable defined above. So shortest path and length. Okay, so what I'm going to do now, I'm going to say, okay, well, my node 1 is now Medici, so I want to go for each node 2 in net.nodes, and then I want to get the distance between Medici, and I'm going to put Medici as node 1, Medici, distance of node 1 and node 2 for node 2 in nodes, and I'm going to have an optional if I don't want to calculate the distance between Medici and Medici. because presumably this will be 0. I'm just going to check this extreme case of the function. It will be 0. We'll just slightly bias the results because I will add 0 and divide over the number of these shortest path. I don't think it makes sense here. I'm going to say just if node 1 is not equal to node 2. That basically should give me a list containing the path between the Medici and all of the other families here. And actually, if I'm curious to see what these paths are, I can make it a dictionary comprehension. I can say, okay, node 2 and the distance between node 1 and node 2, and that will give me the distance between the Medici and all of the other families here. Okay, so far so good. So I'm going to go back to the list and let's call it distances. And the question here is asking me to report the average shortest path between Medici and all other nodes. So what I'm going to do, I'm going to calculate the length of these, not the length, the sum of these distances divided over the length of distances. Okay, so that will give me 1.7 hops on average between Medici and the other families in the network. All right, so far so good. Next question is asking us to repeat this process for all of the families, not only Medici, but all families. So I'm going to use the same strategy here. I'm going to isolate my code here in a function. Actually, let's put this one here. I deleted it. That was the Medici and Peruggi. Medici and Peruzzi. Okay. So I'm going to use the same strategy. I'm going to isolate my code here in a function. So I'm going to call this function shortest path or average distance in between node 1 and all other nodes, right? So because I need only to know node 1, so I'm going to call it node in this case. I'm going to paste this whole thing here. Once again, I need to make sure I don't incur a copy paste mistake, so I'm going to make sure node 1 no longer here. Node 1 is now linking to node in my function, and then I'm going to return. So now if I do average distance of Medici, that's going to be 1.7. Average distance of Peruggi and all of the other nodes in the network should be higher here, 2.7, because this is a more peripheral node here in the network. Next, I'm going to create another list, average distance of each node to all other nodes for node in network.nodes, and that should give me the average distances here. Now I'm going to make it a dictionary comprehension because the next question is asking me this question is asking me to report the average path between each family and all other nodes, and I have no idea what the family is now. I only have numbers. And the next question is asking me to then report back the family that has the shortest distance to all other families. I'm going to call this one all shortest path, and that's going to be a dictionary here. And just looking through the dictionary, eyeballing it, you can see that the Medici here has the lowest average shortest path to all of other nodes in the network. This is important here and interesting. Anecdotally, you probably know that the Medici was the most powerful family in 15th century Italy. If you played Assassin's Creed, you know that. Okay, so now we want to report the family that has the lowest shortest path. I want the minimum of the value, so I need probably to either sort or use the function min on my dictionary. Or I can use pandas. I can create a series and can do idx min. So one way to do it is to import pandas, and then I can do series. I can do a series based on all shortest path, and then I can say idx min to get the index of the minimum one, which is the Medici. Another way to do it is to stick with Python and say, okay, here is my dictionary and I want to report the minimum of that dictionary. Well, obviously this by default will go over the keys, and it's going over the keys in alphabetical order, but I have the option of providing a function that specifies how the minimum itself, the key function, the minimum function is looking at the key. So what I'm going to do here, I'm going to say, okay, do this, but your key is a function lambda x, and lambda x should be the value associated with that x here, and that should give me the Medici here. Either route you go, if you're more familiar with pandas now, that's perfectly fine here. All right, so that answered all of these questions. Before wrapping up, I just want to say that what we have done in terms of calculating the shortest path between a node and all other nodes is something that exists in network X. So we don't need to write these functions because they already exist. Indeed, the function itself, shortest path, you can pass only node 1 and omit node 2. If you do this, you can see it will give you the shortest path in between the node 1 and all other nodes in the network. And then we can process this. We can do another comprehension to map this one to the length -1 actually. And the function itself, shortest path, if you omit node 1 and node 2, you don't give it anything, is going to calculate what we call all pair shortest path. So it's going to give us a dictionary mapping each node to another dictionary that has the other nodes and the shortest path between node 1 and each one of the node 2 in the dictionary. So it's possible to avoid writing our own functions. We just need to process the result of that dictionary. So we can say here, for instance, n to length of n for n in shortest path Medici. That should give me the shortest path to, well, not length n, well, that's the length of the family, so that's incorrect, obviously. We need to get the value associated with that here. Let's call this one path. So we need to go for each n in path, but we need to get the values associated with that path of n. So that should give me the shortest path, or length -1, because I'm taking out 1. That should give me the shortest path in between between the Medici and each one of the families here. So it's up to you, really. Basically, you can use the function shortest path to get all pairs shortest path, and do the processing afterwards.